Alright kiddos, now that we have covered what a mole is, we're going to take it to the next step. Remember in the last lesson we said that moles are essentially a way of counting by weighing, but we didn't actually talk about the weighing part yesterday, so that's where this comes in. You want to pause and copy these notes down real quick, but basically we're going to talk about gram atomic mass, and if you see this box, this is basically like a box on the periodic table. So if you don't have a periodic table out, you want to make sure that you get one. You're going to need one for this whole lesson. But here's the important number, this 15.998. That is what we call the gram atomic mass. That basically tells us how many grams are in 1 mole of that element. So now we know that 1 mole of oxygen is equal to 16.0 grams of oxygen. We round that up. Usually we round to the tenths or the hundredths place. Okay, now that gives us a pretty easy way to do some calculations. So if we get a problem like this, how many moles are in 64.1 grams of aluminum? Okay, so this is we're going to start out much like we did problems the other day. We're going to write our given and our unknown. Okay, so our given, pretty easy in most of these. There's one number, so 64.1 grams of aluminum. We're going to write down what it is in this case. Our unknown is moles, again, of aluminum. Okay. And we don't need Avogadro's number in this case because there's no atoms or molecules. Okay? What we do need is the gram atomic mass of aluminum. So we look on the periodic table, okay, and we see that the gram atomic mass of aluminum is 27.0. Or you might have written down 26.98 if you rounded it to the hundredths place. That would be okay also. Okay? So that number comes from the periodic table. If at any point you're not sure where these numbers come from, look at the periodic table real quick. Check that element, and that is more than likely where it came from. Now, here's what this tells us, though. It gives us an equality of 27.0 grams of aluminum equals 1 mole of aluminum. Okay? That lets us go from grams to moles. Okay? So we start setting up our railroad tracks, given 64.1 grams of aluminum. We want to cancel grams, so we're going to take this 27.0, okay, and come down here. And then the other half of that is 1 mole of aluminum. So then we come to that point. We cross out our grams of aluminum. Okay, and then we're going to punch this into the calculator. Remember, much like last time, you need to make sure that you punch it in the calculator correctly. Stuff in the numerator, you're going to divide by the stuff in the denominator then. Okay, so 64.1 divided by 27.0, round to 3 sig figs in this case, and we get 2.37 moles of aluminum. So we can work the same sort of problems in reverse if we're given moles at the beginning. Okay. Now what you'll notice about these problems is that the conversion factor that we use, the equality that we use, is different in each case because aluminum has a certain gram atomic mass, copper has a different one. Okay, so we're going to use a different one in this case. So again, given 14.5 moles of aluminum, if it says mass, that means we're looking for grams. Okay, when you see mass in chemistry, you want to think of grams usually, unless it tells you something else. Okay, 1 mole of copper is equal to 63.5 grams of copper. Okay, again, from the periodic table. Okay, that doesn't just come from nowhere. It's from the periodic table. Set up our railroad tracks. Put the given 14.5 moles of copper. We want 1 mole of copper on the bottom. Okay, and at the top we want 63.5 grams of copper. That's the other part. And remember, that's the gram atomic mass from the periodic table. Now in this case, so we're going to cancel moles. Alright, and in this case we multiply the numbers instead of dividing. So 14.5 times 63.5. Again, we've got 3 sig figs, so we're going to round to 3 sig figs here, and we get 921 grams of copper. Grams is what we're looking for. That's the mass. Okay, so these are relatively simple. Okay, there's nothing massively complicated. Where they do get a little bit more complicated is when you look at a problem like this. Okay, sometimes we need Avogadro's number and the gram atomic mass. So if you look at problem 5, it says atoms. Atoms is your big clue. If you see atoms or molecules, you should immediately think, I need Avogadro's number. The other half is that if you see grams or if the problem asks for mass, then you definitely need to use the gram atomic mass also. Okay, so in this problem it says atoms, I need Avogadro's number. It says grams, I need the gram atomic mass. Okay, so given, unknown. So since it says atoms, I'm immediately going to jump in, put Avogadro's number. 1 mole equals 6.022 times 10 to the 23rd atoms. Okay, atoms in this case, we're not dealing with a compound. 1 mole of aluminum is equal to, and we've already done that one, 27.0 or 26.98, again from the periodic table. In this case, we already had done one, so we kind of knew what it was. And then we're going to set up our railroad tracks. And the only thing that's going to make this problem a little different is just that we've got two conversion factors, two equalities as opposed to one. So our given, 54.0 grams of aluminum. Okay, we want to cancel grams first, so we're going to take that 27 grams of aluminum down to the bottom. That's going to allow that to cancel out. 1 mole of aluminum on the top. Okay, so the next thing we need is, if we cancel out the grams, we're going to be left with moles. So we want to cancel moles, so we take the moles here, and then we take the 6.022 times 10 to the 23rd atoms at the top. Okay, so stop for a second real quick. Make sure you cancel everything out that cancels. Okay, so grams of aluminum cancel, moles of aluminum cancel, left with atoms. That's going to be our unit, and that's good. That's what the problem asked for. Calculation for this is a little tricky. We'll pop in a little pop-up here for you in the bottom just to make sure, but it's 54.0 times 6.022 E23. Okay, all of that then divided by 27. And make sure you put that top stuff in parentheses. We'll get our answer here. You might have got a little bit different answer if you had done the 26.98. I think it comes out to 1.21. Nothing to sweat. If it's that close, you're not going to miss a problem for something being that close. So number 6, what is the mass of 3.01 times 10 to the 21st atoms of cobalt? Okay. Again, atoms, big hint. Okay, that's our given. Obviously, we're going to write that. We're looking for mass. Remember, mass is always grams unless it says otherwise. And so what conversion factors do we need? It says atoms, bam, I need Avogadro's number. Okay, immediately. And remember, it's always 1 mole. Always, okay? The only time we'll have stuff that doesn't say 1 mole is chapter or unit 10 a long time from now. Okay, 1 mole of cobalt is 58.93 grams of cobalt. Again, this comes from the periodic table. Okay, always remember to look there. And just like the last problem, we got 2 conversion factors then. Okay, so we're going to set up our railroad tracks. Start with our given, 3.01 times 10 to the 21st. I don't know why I'm having problems with first. Atoms of cobalt. Should have put cobalt in there. I didn't, but I'm not going to count you off on that. But you really should, because when we get to stoichiometry later, you'll need to do that. We want atoms to cancel, so I got Avogadro's number down here. Okay, 1 mole on the top, and that, again, that's 1 mole of cobalt. 1 mole of cobalt down here. Okay, this 1 mole comes from this equality, and this 1 mole comes from this one. Okay, 58.93 grams up here. Cancel atoms, cancel moles. We're left with grams. That's what we want. And then it's just a matter of punching it into the calculator. And that one's, again, a little tricky. As long as you've got that E thing down, though, these should be relatively easy. Okay? These are a little step up in difficulty from the mole conversion problems, but I think everyone should have a pretty easy time with these. Just make sure that you work the problems out. And again, especially make sure that you write everything down at this point. You should have given unknown. You should have all your quantities. You should have the railroad tracks. You should cancel stuff out. Make sure you got sig figs in the correct units. All right? Thanks, guys.